Today we're going to look at section 3.5, Basic Matrix Operations. Our objectives are to identify an element, the order, and types of matrices, and to be able to add and subtract matrices. So first of all, what is a matrix, or plural matrices? It's a rectangular array of numbers, symbols, or expressions arranged in rows and columns. So what we do to show that is we use these brackets, and we will have rows of information. Okay, and then we will look at the columns of information that we have. Okay, so for example, if I put 2, 3, 1, 4, this is considered a matrix. It's rectangular in shape, and it's an array of numbers. It could have been symbols or expressions arranged in rows, so this one has 2 rows and 2 columns. So what is the element or entry of a matrix? Well, it's the individual items in a matrix. So if we look at an example, 1, 2, 3, 4, 5, 6, this has 6 elements, or what we call entries. Okay, and we can pick a specific one by talking about what row and what column it's in. So for example, this would be row 1, and this would be row 2. We have column 1, column 2, and column 3 in this example. If I was going to look at the number 6, this is the entry in row 2, column 3. One of the important things about a matrix is what we call the order, and it's the size and shape of the matrix given by the number of rows and the number of columns it contains. So if we look at the same example we had in the last page, okay, we always go by rows and then columns. This has 2 rows by 3 columns. So this is called a 2 by 3 matrix. And again, this isn't 2 times 3, this is 2 by 3. It's kind of like if you were to order lumber and you have a 2 by 4. It's 2x4, but it's 2 by 4. Okay, it's really important that you have this in order. It's always the rows, then the columns. We have a few special matrices. One is called a row matrix, and what that means is it has a single row. Okay, so it could have multiple columns. So 1, 2, 3, 4. If we look at this, the order would be 1 row by 4 columns. It has a single row. Okay. Similar is a column matrix. Okay. A column matrix has a single column. So if I do 1, 2, 3, 4, this example has 4 rows by 1 column. Okay, and this is called a column matrix because it has 1 column. Okay. A square matrix is exactly how it sounds. It has to be in the shape of a square, and we know squares have equal sides. So for example, if I do 1, 2, 3, 4, 5, 6, 7, 8, 9, this would be square because it has 3 rows by 3 columns. Any square matrix, the rows and columns will be an equal value. So today we're going to add and subtract matrices. I'm going to show you how to do this by hand because it's actually probably much faster by hand than it is in a calculator. Our next lesson, when we talk about some multiplication, we are going to get to the calculator usage a little bit to help us then eventually solve. So in order to add or subtract matrices, they must have the same order. So for example, if we had a 2 by 3 matrix, okay, so if we had the order was a 2 by 3, we could add it to another 2 by 3 matrix. Okay, and this isn't the actual matrix, but I'm just showing you. A 2 by 3 could be added to a 2 by 3. If I had a 2 by 3 sized matrix, I couldn't add it to, say, a 1 by 4. Okay, these have to be identical. So we're going to go through a couple examples so you can see how that works. The next thing we're also going to talk about is a scalar multiplication. So it's when a real number, which we call a scalar, is multiplied by the matrix. The scalar is distributed to each entry of the matrix. So let's just do an easy matrix, 1, 2, 3, 4, a square matrix. If I put a 5 in front, this is called a scalar. Okay, it's the number that's multiplied. It's a real number, okay, multiplied by a matrix. So we put it right in front. And remember, when you have no symbol between 2 items, that implies multiplication. So it's kind of like if we had this. If you saw this, you would distribute the 5 to both the x and the 1. We're going to do the same thing here. I'm going to distribute the 5 to each one. So it's 5, 10, 15, and 20 in this example. So this operation, we have 2 matrices. Okay. This one has 3 rows by 2 columns. This one has 3 rows by 2 columns. And you don't actually have to write this out for it. You should be able to physically just look at it and see if they look like the same size. The reason why they need to be the same is because our answer is also going to be 3 rows by 2 columns. And I like to show this by 3 rows and 2 columns, because what I'm going to do is find the answers for each one and then substitute that on. Okay, so if we kind of go through here, to add, because that's what we're doing, that's the operation we're doing, I'm going to do 5 plus a negative 2, which is a positive 3. I'm going to do a negative 3 plus 1 and get a negative 2. And if you notice, this is row 1, column 1. So I'm going to look at the number in row 1, column 1, and add it to row 1, column 1. And that's why they have to be the same, so they match up. To get row 2, column 1, I'm going to look at row 2, column 1, row 2, column 1. Negative 3 plus 3 is 0. And then to get this next one, it's going to be row 2, column 2. So it's 4 plus 0, which is 4. And then for my third row, row 3, column 1 plus row 3, column 1 is going to be 0 plus 4, which is 4. And then row 3, column 2 is going to be 7 plus 3, which is 10. And this would be my final answer. 3, negative 2, 0, 4, 4, 10. All right, so when we look at the next one, it's a little bit more complicated. We have a subtraction inside the parentheses, and then we have the scalar on the outside. Just like order of operations, or please excuse my dear Aunt Sally, we are going to do what's inside the parentheses first. This is a 2 by 2 square matrix. This is a 2 by 2 square matrix, so it's okay to subtract them. Now, what I like to do, instead of subtraction, because for some reason students always forget about this. They start doing the work, they get the first few answers right, and then they forget that we're subtracting. So remember, if you had a negative in front of a parentheses, let's go back to this example, you can distribute it. So this would really be negative x and a negative 1. I'm going to do the same thing here. I'm going to change this to a plus, which distributes this and makes this a plus, minus, minus, plus. Now I can add the two numbers, and students tend to add naturally and not subtract. So I'm going to remember to put my scalar out front. I know that if I add a 2 by 2 to a 2 by 2, I'm going to get a 2 by 2 matrix. Okay. 1 plus 4 is 5. 2 plus negative 5 is a negative 3. 0 plus negative 6 is negative 6. 3 plus 8 is 11. Okay, so first thing I did was combine the ones inside. Now I'm going to use my scalar multiplication and distribute the 2 to each of my entries. 2 times 5 is 10. 2 times negative 3 is negative 6. 2 times negative 6 is negative 12. And 2 times 11 is 22. And this would be my final answer, a 2 by 2 matrix. All right, let's look at our third example. Now, if I look, this looks a little weird. So let's kind of think about what the order of this matrix is. This is one row by 1, 2, 3, 3 columns. This is one row by 1, 2, 3, 4 columns. These are not the same, okay? And if they're not the same, then it's impossible for me to add or subtract because the entries won't line up. So this one has no sum. Okay, it's impossible to add those. Now, if this was subtraction, it would have no difference, and that's how we would answer it. But this one, since it's addition, has no sum. So let's look at something where we actually have to solve, a little bit more complicated. Okay, so if I look at this, I have an x and a y that I'm solving for. So let's look at what we have. We have a 2x here and a y down here, but I have the scalar multiplication. So what I'm going to do is actually rewrite this as 2x, 8, 4, and negative 6. Now you might get to the point where you can do a lot of this stuff in your head and you don't have to do as much as work as I'm showing right now, but for your notes it's probably a good idea to actually do all of these steps. So when you look back you understand what happened. 3 times 3 is 9. 3 times negative 2, negative 6. 3 times negative 5 is negative 15. 3 times positive 5 is positive 15. Okay, So now that I have this, what I'm going to do is look at where my x is. My x right here happens to be, let me change the color for you, in row 1, column 1. So I'm going to circle all the row 1, column 1s. And what I'm going to get is an equation. I know that the rule here says I take 2x and I add it to 9. But the equation tells me that should be equal to 5. So I'm just going to solve this by subtracting 9, which gives me a negative 4, and then dividing by 2, and I get negative 2. Likewise, I'm going to do the same thing for y, but y happens to be in my solution, and that happens to be in row 1, column 1. So I'm going to go to all the row 1, column 1s, which happen to be there. And now I'm going to do the same thing. This is 4 plus a negative 15 equals y. So I can just combine like terms. I get negative 11 equals y. And that's how you set up a problem where you have to actually solve for x and y. So hopefully you feel a little bit better about basic matrix operations, and that you feel that you're able to identify what an element of a matrix is, what the order of the matrix is, the type of matrix, our special ones, and to be able to add and subtract matrices